Hi there. Today's a beautiful day and I get to sit and code on my iPad in my backyard, and all thanks to cloud development environments. In today's video, we're going to talk about Coder, which is a great product that I've been testing for over a week now. I have ex-colleagues from Docker, from HashiCorp working at this company, so it's really good technology that I can really recommend. So why don't we dig in and take a look? This is going to be a 3-part video series on Coder. And this first video, we're going to see how we can onboard developers quickly and enhance their productivity. So we're going to first ask the question, why cloud development environments in the first place? Then we'll see the benefits of using Coder over traditional development methods. We'll take a look at Coder's architecture. Then we're going to take a real-world example with Palantir's onboarding success story. And we'll wrap things up with a demo and show you Coder in action. So why cloud development environments in the first place? And how do developers code today? Today, you might offer a developer laptop to every new developer that joins your organization. However, there are a few issues with that. You might run into code escape risk, right? The code will live on their laptops, so there's risk, of course, from an IP perspective. There's also configuration complexity. The platform team or the IT team now needs to configure those laptops, get them ready for the developers. There's also poor observability in terms of what's going on those laptops. Also, some organizations have virtual desktop infra or VDI. With that, there comes the issue of sometimes high latency, poor developer experience, and also limited flexibility. Also, you can use shadow virtual machines, so you can run a VM, let's say in AWS, but with that comes poor governance, increased operating costs, and sometimes also wasted time. What's interesting, though, is that we have CI/CD pipelines and deployments that run inside of clouds, whether they're public clouds, hybrid, or your own private cloud. So why not take that development workspace and put it in the cloud as well? However, the outcome of what we just talked about in terms of developing on a local machine is that you end up with developer productivity and experience that's sometimes frustrating and time intensive for your developers. From an operational efficiency perspective, it can be very inefficient and costly. And from a governance and control perspective, it's also pretty risky. So Coder proposes that basically you move the Coder IDE or the workspace into your own cloud, similar to what we're doing with CI/CD pipelines and deployments. And you offer a laptop that is much more lightweight to your developers. And from here, they use a browser or a desktop IDE on their laptop to access workspaces that you build for them in the cloud. So customers choose Coder for a few reasons. Number one is open source distribution model. The core features are freely available and usable by anyone. In fact, I'm using it right now to build some of my playgrounds for the Tech and Aid Academy. Number two is self-hosted platform. You bring your own cloud tenant or host Coder in an air-gapped on-premise environment, so you have that flexibility rather than using any of the cloud development environments that are hosted in somebody else's cloud and you don't have much control over them. Number three is performance and scalability. So there's powerful networking enabled. Terraform is used to build templates, which we'll see in the demo, which is very, very powerful. And number four, it's cloud and IDE agnostic. So you meet your developers really where they already are with the tools they're already using, and it's highly customizable for the developers. Let's take a look at Coder's architecture. So at the center here, we've got the control plane, which is running the Coder daemon, exposes the REST API, dashboard, provisioner D with Terraform. And that's tied to a data layer where we have our Postgres database. There's, of course, container registry, machine images, Git, and so on outside of Coder that you access. And then there's the idea of workspaces. And these workspaces can really be hosted anywhere.
You can build workspaces inside of Kubernetes, which we'll see in the demo, in a Docker container, in a VM. And each one of these will run an agent. And you'll also need to provide some sort of persistent disk to save your workspace, and you can restart it, stop it, and all your data is still there. And there's quite a bit of flexibility in terms of where to put your workspaces, using Terraform to build workspaces. Then your developers can access these workspaces either through a web IDE that connects directly to the control plane, or through a desktop IDE that will talk directly to the workspace. Now let's take a look at Palantir's onboarding success story. I'll put a link in the description of this video for you. What they mentioned was that they saw an improvement of 78% for their front-end build times using Coder. Their Git clone times improved by 71%. They used to offer 32 gigabyte M1 MacBooks, which cost $2,900 for 2 years, which is about $1,500 per developer per year. Now with Coder, they're offering laptops that are $2,000 and are standard M1 MacBooks, which costs roughly $1,000 per developer per year. Of course, you got to add the EC2 instance costs. And in their organization, they're more heavy on the memory side of things. So they've decided they're going to use R5.4x large instances in AWS. That costs about $1 and some change per hour, which is approximately $8,830 per year. So there are some cost optimizations that they took into account as well, such as fitting 3 developers per one of those EC2 instances. Instances are on for 5 out of the 7 days, and instances are on for 12 hours per day. Their overall cost increased a little bit by 41%, but that was offset by an increased productivity and better operations and maintenance. They also provide this in their blog post in terms of some of the calculations they had with the MacBook, with the 32 gigs costing them about $1,450 per year. And then the calculations they had with running Coder, of course, with workspaces that are running in EC2 instances in AWS. All right, let's take a look at our demo scenario. And here we're going to see how we can onboard a new developer in a 50 dev shop using Coder. And 50 developers is where you can get away with Coder's open source. After that, if you're more than a 50 dev shop, you're definitely going to want to look at using Coder Enterprise. So the steps that we're going to run through is basically we're going to set up a Coder instance in a Kubernetes cluster. We're going to create a template for workspaces. We're going to demonstrate the onboarding process from a developer's perspective. And finally, we're going to show how Coder reduces onboarding time and enhances productivity. So let's get started with our demo. Let's build our Coder instance. The only thing we really need is a Kubernetes cluster. And then we're going to create a namespace and call that namespace Coder. Then we're going to need a Postgres database. So simply use or create that database with Helm. So we're going to get the Helm repo added here, and then we're going to go ahead and run Helm upgrade install. Let's change our namespace to Coder, and then let's get everything here, and we see already our database is up and running. Next, we want to create a secret so that Coder can access the database. Of course, you can change the secret. This is just generic here for the demo. And finally, all we need to do is install Coder itself using our values file here and a secrets YAML file as well. So we're merging both, and that should do it. We can now go ahead and take a look at the deployment, and we see that we have Coder running right here in the pod, and we've got our database running, and everything looks great. We now just need to access the actual UI. So I have an ingress running in my cluster. So if you look up ingress, you can see it here, and I'm running this under host coder.techonaid.com. So I should be able to access this directly from that URL. So here we go. We're on coder.techonaid.com, as you can see, and this is the first time we're running this. So it's asking us to create a user account, an admin user account. So I'm going to go ahead and create that. And give it a password. Go ahead and save that. And I'm going to skip the 30-day free trial for now, as we're just looking at all the open source features that Coder has in this particular video. We're greeted with the UI here, and we're looking at the Workspaces tab. So we have no workspaces at the moment, and it's telling us to go to templates. So we're at the templates tab, and here there are a few starter templates that we can use. So I'm just going to pick the Kubernetes template. Since we're building this on Kubernetes, we'll leave it called Kubernetes deployment. So provisioning Kubernetes deployments as Coder Workspaces. Go ahead and create the template. And we got to fill some variables out. Leave that. And here, we're going to build our workspaces in the namespace Coder, and also the kubeconfig is the one we're using since we're already on the same Kubernetes cluster. So we go ahead and click retry, and this will actually build our template for us using Terraform. And you can see the source code for the template right here. Terraform, the required providers, Coder, Kubernetes. These are the providers we're using, and you can go ahead and take a closer look, which we'll do later on. All right, now let's go back to Workspaces, and now we can create a workspace based on the template that we just created. So here we can give it a name, workspace. And this one has a few parameters that we can use. So we can specify CPU, number of CPUs, let's say 4 cores, 10 gigs, and maybe memory 4 gigabytes, and click create workspace. And what happens here is that Terraform is actually building a workspace for us, and it will be ready very soon. And I can see also that it's going to get stopped in a day, and I can reduce that. So I can subtract a few hours from here, which is pretty neat. So this is complete. I've built it in no time, and we have 3 buttons that I can click on here. A terminal. So I get dropped here into a terminal, and of course this is Linux. So you can see Linux commands that I'm running over here. Looks great. And I also have a code server, which is pretty much VS Code in a browser. So I can see what you expect from VS Code. And this is not really the theme. I like darker themes. So this theme here, maybe this one, that looks much nicer. And I can see all my folders, and I'm dropped in the home folder. So if I look it up here, I'm on home coder. That's the home folder. And very similar to what we saw before. I can build, I can create files. Maybe this file will see to test persistence. We can close that. And finally, VS Code desktop. So I can open this workspace in my native desktop VS Code, right? Running on my Windows computer here. So hitting Control J will open the terminal at the bottom. And I can open my folder here, can open folder, and I get dropped in the home folder. Yes, I can trust this. Control J again to see my terminal. I see my test.txt is still here. That looks great. And I have VS Code experience. I can download extensions and install them. I see the Coder extension here. And yeah, it's pretty neat. All right, so one more thing I want to show you here is that we can actually stop this workspace. All right, so let's say I'm done working in this workspace for now. I can stop it, and it has stopped already. I can go ahead and build it all over again or just start it. So when I start it, I'm going to make sure and check that our file is still persisting, that text file that we just created. So let's go ahead and maybe open a terminal. I can see my test.txt file. Testing persistence is still there. That worked. So persistence works very well. All right, so I can see my templates here. I can see that I'm the only user. I can take a look at some of the deployment stats. Here's my access URL. I don't have any licenses. Appearance is an enterprise feature. You can change the logo. You can change the name of the application to say something other than coder. User authentication, I actually have GitHub enabled. So you can allow GitHub authentication for users. And that's external authentication that I have here. You can check some network parameters. Workspace proxies is an enterprise feature that allows you to access the control plane from multiple places. And that really reduces latency. And if you noticed, when we ran commands inside of CodeSpace, whether we were using the, in here in the workspace, whether we were using the VS Code desktop or code server, latency was pretty good. And there's a measurement right here, 21 milliseconds. So you don't get type ahead errors or things like that that are quite annoying. So it's a very great experience. So you can see here, this is quick in typing. I'm able to work with this really fast. This actual VM where I'm running Coder, and I'm running it in Kubernetes, is hosted in Ashburn, Virginia on Hetzner's cloud. So it's not too far from me here in Toronto, Canada, but you can see the experience is really good and really fast. I'm not getting any kind of latency while I'm typing. And again, it's giving you a measurement right here. And a few more metrics that we can look at here in the health. So this is great. I can now spin up a number of workspaces based on different templates, and I can use the VS Code desktop or code server or a terminal. So I use this one when I'm using my iPad, the code server, as I showed in the beginning of this video. Now that we've seen how easy it is to stand up Coder, let me show you how you can start onboarding your users. As a platform engineer, you're going to onboard your developers, right? If I log out from here, sign out, you can see that I've already integrated GitHub authentication. So let me log in with my GitHub as a developer. So of course you need to put in your username and password for GitHub. So this is another user here. And right away, this user is dropped into their space, and you can see that they don't have access to everything that the admin user had. So they can only access workspaces and templates. So whatever templates you expose to your users, they're able to go ahead and create a workspace like this. They can choose whatever they need, and then they can go ahead and create their workspace. And as an admin, you can see all your users and who has access to what. And again, you can enforce how long they can use the workspace for, which will be the topic again of our next video when we talk about resource allocation. And you'll see that you'll be able to limit, let's say, 10 hours a day or something, or 24 hours. And after the 24 hours and after Coder detects that there is no activity in the workspace, it will stop the workspace. And of course, that will reduce cost. So here's the user. They're connected. They're good to go. They can jump into, once again, their workspace, do their work. And when they're done, either stop the workspace or walk away, and it will stop on its own. And if I log out from here and log in as my admin user, you can start to see here under workspaces, owned by me. If you remove this filter, you can see the second workspace and the owner, TechNade here. of that workspace. You can see the users, and you can continue to add more users and authenticate them using your single sign-on, which is an enterprise feature, or GitHub, which is part of open source. And that's how you'll onboard all your users, right? You can see their login type as well here. And it's so simple to get your developers up and running and managing it from your perspective as a platform engineer. It can't really get any easier than this. Now, I did promise you to walk you through the template and show you the actual source code, which is basically Terraform code. And really, the sky's the limit in terms of Terraform, right? You can build a template that, and I've built it before, and I'll show you in the next video, where you can spin up a workspace in Hetzler's Cloud, for example, or AWS, or Azure, or GCP, wherever you want to spin up a workspace, you can do it with Terraform very easily. So you can see here the providers, coder and Kubernetes, provider coder, variable using the kubeconfig, a variable namespace, and then we've got some coder specific data blocks here. So this is a coder parameter CPU. This is the options that we saw, 2 cores, 4, 6, 8. So we can expose these parameters to the user to select. Here's the memory, and here is the home disk size. We've got our provider Kubernetes, and we're using our kubeconfig that, since we're already deployed, as I mentioned, on Kubernetes itself, so we can leverage that. Coder's workspace and coder workspace owner that we can leverage later. And then the coder agent, which is what is basically going to run in your workspace. And here we're installing code server. You can have a script, a startup script that you can run as the workspace launches. So here we're just deploying and installing code server. And some metadata, and this metadata is what we were seeing in the workspace, kind of some of the stats in terms of CPU usage, RAM usage of the workspace, the home disk, and the CPU and memory of the actual host. And here is a resource coder app to expose that coder server button or code server button that we can click on and get access to a web browser that is running code server. And then we've got our Kubernetes persistent volume claim. This is how we're creating persistence across stopping the workspace and restarting the workspace. We're able to have that with our PVC here. And then we've got our Kubernetes deployment, and we've got a replica of one, security context, and then we're running a container, and there's an image in this container. We're using Coder.com's enterprise base Ubuntu image, and really this image can be anything. And I'm going to be using an image that I build with Docker that's going to have Docker, Minikube. It's going to have some of my favorite tools that I can use. And you can embed all that inside your Docker container and build it and publish it and then call it from here. And it will run right away as you're building your workspace. And you have all the tools you need embedded in your workspace. Some resources and limits and requests. Our volume mount is the home folder is home coder. And we're calling our persistent volume claim here, our PVC. And we have some affinity here for pod anti-affinity. So that is it. It's pretty simple. You can see here it's one file with a README as well. So you can see what this is all about. And you can deploy this however you wish. If you need help with Terraform, you can check a bunch of videos that I have on this channel regarding Terraform. It's an incredible infrastructure as code tool that can help us build any kind of infrastructure that we desire. So I'm really glad that Coder decided to use Terraform to build these templates. It's a very powerful tool, allows us to do quite a lot, and it's quite familiar to many of you, many platform engineers and DevOps professionals. So really there's not much to learn here, and it was very easy for me to get started with Coder. As you've seen in this video, setting up and using Coder can significantly enhance developer onboarding and productivity by leveraging cloud development environments. we've discussed the benefits of Coder over traditional development methods. And through a step-by-step guide, we demonstrated how to set up a Coder instance on Kubernetes, create and manage workspaces, and integrate with VS Code both in browser and via the desktop application or IDE. Stay tuned for the next video in which we'll explore creating more powerful and customized templates to enhance the development workflow even further. We'll also discuss how to optimize resource utilization to reduce costs with Coder. Thanks for watching.